for all of your automotive style air conditioning. All right. I want to take this moment to thank you guys for coming out, spending some time here with us. I hope the information I provide will be useful to you. There's a ton of information in the booklet, a lot of regulations, a lot of rules, but there's also a lot of other information that's good. So with that, we're going to get started. I'm going to start you off with history of R12. It's the ancient stuff, it's the stuff that we started with. Those of us that were around know that this was what we all worked with, this is what we got started with. It made its debut in 1930. Can't even imagine Grandpa and Grandpa running around with air conditioning in their cars, but they did, if they could afford it. The industry hailed it as a miracle chemical. It was something that they could use to cool off that compartment and make the population happy and cool and more comfortable. In 1970, they suspected that it was depleting the ozone layer. That was in 1970. It wasn't until 1985 that they were able to prove the effects of it. They actually were able to show the thinning of the ozone layer, and over the Antarctic there was actually a hole where there was none. Now, the Antarctic is a long ways from here, but it affects us also. As it thins, it is what filters out the ultraviolet radiation. That's what causes our sunburn, that's what causes cancer, that's what causes cataracts. Without that filter layer, the earth would be pretty hard to live on. There's some other things that it does that we don't see, and one of them is it affects the sea life. It actually reduces the plankton growth in the sea. Without plankton, the sea life drops off. We all know that we like a good fish sandwich or a little sushi here and there. Without the plankton, that would become a lot scarcer. Become a lot harder to find. And R12 had a global warming potential of 10,900. Now they put this on for chemicals so that they know how they affect the atmosphere, the earth itself. This one has a 10,900 rating. It was replaced entirely in 1994 for production purposes by 134. 134 they found could retrofit into where R12 was. It was a very good fit for it. Ran with similar pressures, similar temperatures. It is not an ozone depleting substance. It doesn't break down the ozone. The ozone is actually starting to replenish itself. It is starting to build back up. They say that by the year 2050, if everything stays on course like it has been, 2050, it should be completely replenished where it was originally.
What was that number, that 10 potential rating?
That's the global warming potential. That's the potential it has to hold the heat into the earth.
What is that number?
It's a rating scale that they developed for the different chemicals. I can't give you exactly what it is, but I will tell you carbon dioxide is rated 1. Carbon dioxide does not cause warming of the earth. Okay? So, 134 has a global warming potential of 1430. That's a huge drop from where we were. But it still has a fairly high number. Okay? It still can add to climate change. And we've all heard about climate change. The melting of the ice caps. It does happen, it is real. As of 2021, they ruled that R134 cannot be used for new production. So this year, they're going to stop using R134 for new production of automotive vehicles. They will have other options that they will put in. By 2026, they're going to say they can't produce any vehicles with it. Right now, they're still producing some vehicles to be sold in underdeveloped countries. So they're going to give it a 5-year time frame to phase that out. So, where we go? You've all heard, I'm sure, of the 1234. 1234 is got a global warming potential of 4. CO2 has a global potential of 1. This one has 4. Very good option for what we're looking for. Pressure and temperature is very close to the R134. R134 is very close to R12. It requires less redesign. Therefore, the auto manufacturers are already putting compressors on, already putting condensers on. All they have to do is change over to the components that can be used with this. They're very similar in size and shape, so it's really easy for them to switch over. It's the least expensive switch. Now, the 1234, if any of you checked, is a higher price. There's less demand out there for it at this time. It's going to be more. As it increases, of course, the price will come down on 1234. But for the auto manufacturers, they're building right into the price, and it's similar to 134 for new production. It does have a slight flammability to that substance. It is not mixed with anything. I've heard in the past that, hey, yeah, they're mixing it with a propellant like propane or something to make it. No. This is a whole different substance. It does not have anything else added to it, but it does have a flammability to it. If you subject it to a spark or an open flame, you can get it to burn. So we want to make sure that you're staying safe, staying away from ungrounded electrical cords. 152 is an alternative also. It's got a GWP of 124. I haven't heard much of 152, so I'm not really thinking they're going to use that one anywhere, but it is an option. These are the only three as of this year that are acceptable by the EPA for refrigerants in automotive vehicles. This R744, which is CO2, is got the GWP of 1. This is one that the German auto manufacturers have decided to go with. It takes a lot higher pressure to do what we need to do. The design of the system is going to be a little different. It'll still operate pretty much the same, but it'll be a little different design. And it has the potential to displace oxygen. So, along with using this in the car, they're going to have to design a CO2 detector for the passenger's compartment. That'll have to be built into the vehicle. If you get a leak on an evaporator in one of these vehicles, it's going to set that alarm off. The first most important part is we got to go through the regulations. Regulations are very important for everybody to know what they are, why they're there. Section 609 of the Clean Air Act Amendment of 1990. Now, if you remember my earlier slide, 1985 is when they realized that they were able to prove that it was depleting the ozone. It took them 5 years to come up with the regulations that they needed to put in place. They went back and forth in the federal government getting this set up. So the EPA sets the regulations. Society of Automotive Engineers will set the standards that are required. And then the DOT and United Underwriters Laboratories will do the testing. They test the equipment, make sure it meets those standards. All right? So, this standard says anyone repairing or servicing MVAC system for hire must be properly trained and certified by an EPA-approved organization. We are doing a certification through ASE. ASE is approved for this certification. They make sure that we go through a class like this, make sure we go through the testing, and the testing is an open book test. It also prohibits the sale of Class 1 refrigerants in containers smaller than 20 pounds. It sets the requirement for refrigerant handling equipment. That's all in this Clean Air Act. As of January 1st, 2018, just a couple of years ago, proof of certification is required in order to purchase refrigerant in containers larger than a 2-pound container. Now, the 2-pound containers, the 1 and 2 pounds that you see in the automotive stores, they had a change that came into effect also at that same time, but they are still exempt from that regulation. They can still be sold as long as they have a self-sealing valve on them. If you've seen the change that's happened on them, most of them are coming now with a gauge and a hose on them. So you can hook them up, open them up, get refrigerant out of them, shut them off. It's got a gauge on there so you can see what kind of pressure you're seeing. Alright? This section, 8236, sets the standard required for equipment use in recycling and recovery of each type of refrigerant. Each type of refrigerant has its own regulation standards for it. If you're using R12, it's got one standard. If it's 134, it's 1234. Each one of them is set up right here. That's for the recycling and recovery equipment. They also have standards set for the purity. The refrigerant that comes from the manufacturer has to meet these purity standards. The 134 limits moisture to 50 parts per million, oil to 500 parts per million, and non-condensable gas to 1.5%. Quick and easy to say that. The air we breathe is called a non-condensable gas. You can pressurize it and pressurize it and pressurize it. You can get the water out of it. It'll drop the water out. But you won't get it to turn into a liquid under normal circumstances. You'd have to take some extreme pressures to get it to change. So it's considered a non-condensable gas. It won't condense down. Use of recovery equipment, as long as recovery refrigerant is sent to an off-site where refrigerant is reclaimed and recycled. Okay? If you're pulling a refrigerant out of the system and you're not going to put it back in the system, you're going to collect it, you're going to have to send it off-site to have it tested and cleaned. That refrigerant has to meet these guys. And in most cases, what you pull out of the system, I will not meet these guys. All right. Section 82.42 establishes a requirement that anyone servicing an MVAC system for hire need to be properly trained and certified by an EPA organization. The new piece that came in January 2018 is record keeping. I sell you refrigerant. I need your certification number. I have to keep that on file. If the EPA comes in and wants to say, where have you sold all your refrigerant and who have you sold it to, I've got to show that you guys have been certified to handle that refrigerant. Or you're working for a company that has people on staff that are certified. I labeled this SAE standard as the umbrella standard. They don't call it that, but I do. The reason I call it that is because it has all of the designs on the table. This standard sets the standards for system design, the types of fittings, the types, size of refrigerant, the fitting size for refrigerant, key components used in the system, the pressures, what the service interval is, how to service that. All of those are in that one standard. And that standard becomes an awful lot of what we see. All right. Getting into the system. When that system comes into you, believe it or not, I just did my first class with a repair shop. For you guys with fleets, you guys know what refrigerant's in that system because you can look back on your records and you can see what was done with it, when it was done, who worked on it. When it's at a repair shop, they don't have that. They have to rely on that driver to tell them, hey, I had this repaired at this place 3 months ago, or hey, 2 years ago I had it into this place. They have to rely on the driver to relay this information. So you guys have got a little bit of a step up in the fact that you know what was done. Without those records, they're at the mercy of what the driver's telling. First thing we want to talk about is safety. We always want to wear safety glasses. We always want to wear gloves. Refrigerant in the liquid form boils at a temperature well below zero. Means you take that refrigerant in this room right here and you just throw a glass of the liquid out, it's going to evaporate before it hits the ground. Because it evaporates that fast, it pulls heat away from whatever it touches. So you put liquid on your hands, you will have frostbite. It will cause damage right away. Work in a well-ventilated area and avoid breathing the refrigerant mist. Refrigerant mist is heavier than air. It goes down. If you breathe it, it's going to settle in your lungs. It's going to displace some of your ability to take a deep breath. Stay away from breathing the fumes. Never use shop air to clear a refrigeration system. Shop air, even though it's non-condensable, has moisture in it. When you put moisture in the system, it will mix with the chemicals in there under pressure, under heat, and it causes it to be an acidic situation. A lot of what's in the refrigeration system is aluminum. That acid will eat away at it and keep the moisture out. That's why we put a dryer on there to help pull that moisture out of it. Never use a disposable tank for storing recycled refrigerant. They label them disposable for a reason. When they're filled at the factory, they're filled liquid. Liquids doesn't have much pressure. It's only when it goes to a gas that it's going to try to build pressure. If you're trying to compress that down to a liquid, it's going to take a lot of pressure to do that. When you do that, it's going to be more than what that disposable tank can handle. Do not reuse a disposable tank. Never fill an approved storage tank more than 60% of its gross weight rating. The tanks, like I said, take a lot of pressure to push that down and get it into a liquid state, which is what you're after. So you'll get about 60% of its gross rating in here. If it's a 30-pound tank, you're going to get about 18 pounds of liquid in it, and that's all you're going to get. Never use an ungrounded extension cord. You do not want sparks. With 152, it's very flammable. A spark will set it off. Never use a storage tank that is not DOT approved for refrigerant. It actually has a stamp right on top that says DOT, and it says 4BA or 4BW. You need to make sure you're using a certified tank to recover the refrigerant. Most of your tanks that are for your recycling recovery machines are already approved for that. This is a key one I did not realize until I read through it this year, is that you can never imply that repairing the leak is required. There are only a few states that have put in legislation, statewide legislation, that says you have to repair a system before you can add refrigerant. Iowa does not have that. Somebody comes in and says, hey, I just need you to add a little refrigerant, it's just not cooling right. By law, you can add refrigerant. You can top it off. However, it's not going to prolong the life of that system. As I'll show you, the lubricant that's in the system travels with refrigerant. So if you're leaking refrigerant, you're leaking out the oil. If you add more refrigerant to it, you have no idea how much oil is leaked out, but you add more refrigerant to it, the system will cool for a while. But then due to lack of lubricant, you could have a compressor failure. Let's walk through the system. The compressor, it's a pump, that's all it is. It takes low pressure gas, makes it high pressure gas. That's its job. It just compresses. Here's the condenser. The condenser is named that because what it does is it takes the high pressure gas, lets it get rid of the heat, and when it gets rid of the heat, it drops off to a liquid. That's where your change of state happens from high pressure gas to a liquid. Now, a liquid's still under pressure, but it's going to drop down, and it's going to, when it does that, it gives off that heat. It goes to the dryer. The dryer has two purposes. Number one, it's there to dry the system. It wants to take any moisture that's in the system, take it out. We don't want moisture in that system. The second thing it is there for is it allows the final change from gas to liquid. If there's any gas that gets here, it will collect in that little tank, and then it will only pick up the liquid. We only want liquid going to the expansion valve. The expansion valve is our check valve. It's what blocks that high pressure. It only allows a small amount to go through, so you get a change from high pressure liquid to a low pressure liquid. Now, refrigerant, as we all know, likes to be in low pressure because now it can boil off. When it boils off, it absorbs the heat, pulls the heat in, boils off, and it turns back into a gas. That low pressure gas is what we're looking for. That's the system, the components. We run a line from the compressor down to the condenser, high pressure gas. From the condenser to the dryer, high pressure liquid. All that heat has been pulled out of there. It allows it to drop down into a liquid. And it goes over here to the filter dryer where it's dried, screened, we've got a screen in there, and it's allowed to finally change all that gas to a liquid. We want no more gas bubbles in there. We go from there to the expansion valve, all high pressure liquid. From the expansion valve, it runs over to the evaporator, all low pressure liquid. You drop it from high pressure to low pressure. Now we run the low pressure gas back to the expansion valve. The expansion valve reads pressure temperature relationship. Whatever the pressure is in that low pressure gas coming back to it is going to be comparable to the temperature that's coming across that evaporator. When it sees it a little bit too high, it's going to restrict a little bit. When it sees it a little bit low, it's going to open up a little bit. It's trying to keep that pressure coming back to it at a certain point. And then from the expansion valve to compressor is all low pressure gas. Compressors do not like liquid. No pumps that we have like getting liquid back to it. There's a small amount of oil that goes through, it helps lubricate everything. It's in small enough amounts that it's not going to cause any problem with that compressor. But we do not want liquid getting back there. So to help this system out, we run a fan across the front. Just to point to you, that condenser is very similar in temperature to the pressure inside. So if it's 100 degrees outside and you're running 300 psi in that high side, what's the temperature of that condenser? Pretty close to 300 degrees. Be careful, that's hot. We run a fan across there to help get rid of the heat. The heat comes out of there, it condenses down to the liquid, that's what we're looking for. Now we go to the other half of it, we blow air across the evaporator, and we get happy dryers. When you blow that air across that cabin air across there, it pulls 40 degrees out of the vent, and the guy is just through. He's going to go away and leave you alone for a while. If we have an orifice tube, the orifice tube uses an accumulator, which works just the opposite of the dryer. I'll show you that in a minute. But the orifice tube is a set orifice. It's a set size restriction all the time. So, we got a system out there running. When we changed from R12, which was a fairly large molecule, to R134, which is a fairly small molecule, they found out real quick that that 134 would go right through the brand new hose. It'll leak right through that hose. So they had to fix that. They put a barrier on the inside of that, basically a nylon tube inside the rubber hose. With that barrier hose, I didn't have the problem of leaking through a brand new hose. What we didn't realize was, after a few years of heat, temperature, jostling around, these hoses will cause small cracks on the inside. Those small cracks will chip off that nylon, and it becomes like fingernail clippings. They fall through the system, and they end up over here at this orifice tube. Once you get a few of those nylon clippings inside there, what happens? We change the orifice. It's a different size. Now you don't get very good cooling. In the book here, we've got a pressure temperature chart. It shows you that as temperature goes up, so little pressure is in the system. That refrigerant kind of mirrors the outside temperature. If that system is just sitting there at 60 degrees and it hasn't been run all weekend, you're going to run about 60 pounds of pressure inside that system. On the other side, if it's 110 degrees outside and it's sitting out there, hasn't been run all weekend, it's running about 110 pounds inside that system. Always pay attention to your outside temperature when you're working on a system. Make sure that you're looking at your temperature relationship chart. As the temperature outside comes up, the pressures will increase in that system. If you charge a system up and it's 60 degrees out, and you're looking for it's 135 to 155 on the high side, once you get there, you're gonna say, hey, I'm good, I'm at that system, we're good to go. What if you were looking for 250 to 270? You're gonna overcharge that system. When it's normally 90 degrees out, that's when you work on it the most. The driver complain it's not cool enough. That's the pressure you're gonna get used to seeing. When it's only 60 degrees out, it's much less than. By the other side, if you're used to seeing the 145 to 170 because it's 70 degrees out most times, you find a day when it's 100 degrees, you're looking at 300, 325. So if you just charge it up to where you're at with 145, 160, you're going to undercharge this. It's not going to have enough refrigerant. Now, this was with R12 and 134, you see this. With 1234, you're going to be going more with evacuating the entire system and then filling it with what it's manufactured to hold. They'll tell you right on that compressor or near the compressor that it's supposed to have 2.8 pounds. It's supposed to have 2.2 pounds. When you evacuate it completely out, that's what you're going to put back in. That's what that system's supposed to have. Our condensers have changed over time. Originally, we had the old tube and fin condenser. It had nice big tubes, the refrigerant flowed through it. You got rid of some heat. Everything worked pretty good. That was the old R12. With 134, they came up with a serpentine condenser. It's just a ribbon that goes back and forth across, basically mirrored what we had before. But it did a better job because you had multiple ports to run the refrigerant through. And it did a fair job of getting rid of the heat. What they're finding now is it's not holding back enough, it's not getting rid of enough heat because they're having to use less and less refrigerant. So they've gone to what they call a parallel flow condenser. The parallel flow condenser basically has a tube on either side that has blockages in it that are offset, so it forces it to go back and forth across the system. Our size on those ports to run through those passages have gotten smaller and smaller. Here's a push pin on here, and you see the ribbon style here, and here is the parallel flow. Now, the parallel flow just goes straight across between tubes. If you have a compressor failure, if you have the nylon clippings getting loose, if they get back to this condenser, on this style, you may plug up a port or two. On the parallel flow, it will get into those ports and you can't get it back out. Here's an example of what I'm talking about. It comes in through here, it's got these three that it can go across on, but it's blocked right here from going any further down. Over there, it's got a block further down, so it makes it come right back, and it just goes back and forth. If you're trying to flush out this type of condenser, there's no way to force that material out of that condenser. So if you have a catastrophic failure on a compressor, on anything newer than 2010, change out the condenser. Put a condenser along with a compressor and put a dryer on. If you open the system, you want to replace the dryer. If you take a dryer right now, pull the caps off of it, bolt it on the side of the frame, hook up the hoses to it, put it in a vacuum, you're going to lose easily 25% of the life of that dryer. It is that thirsty for water. It'll pull it right out of the air. Here's how our dryer works. That high pressure liquid comes in the top. If it's got any air in there, it's going to come right in here and it's going to collect up here in the top. It comes on down through this desiccant, which is what pulls the moisture out. It's got a screen on the top and the bottom to help hold that all in place. It forces it down so it's strictly liquid, and it pulls the liquid right up here and right off to your expansion pump. That's how the dryer is built. So an accumulator works just the opposite of the dryer. I told you that the dryer is very thirsty, it likes water. The oil that's in the system is a PAG type oil, it's a synthetic oil. It is very thirsty also, hygroscopic. If you took this container, brand new, took the lid off, popped pop the seal on it and set it on your toolbox. You come back in and overnight, the next morning you come in there, you'd have a mess all over your toolbox. It would literally overfill that container and flow all over the side of your toolbox. It likes the moisture that's in the air, it pulls it right out. It's also a skin irritant. Make sure you're using your gloves. You don't want to get it on your hands, it'll irritate. It is not compatible with mineral oil. However, all of the assembly instructions you'll see will say put a small amount of mineral oil on the O-ring before you put the O-rings on. That's to lubricate those O-rings so they won't roll, so they won't cut, so they won't catch. It will not bother what's in the system. PAG oil is what you need in the system to lubricate the system. In the book, there's actually this chart right here. Shows you if that system's sitting outside over the weekend, here's where you can expect the oil to be sitting, and this is how much. That compressor will have just a couple ounces in it. The evaporator condenser, a couple ounces. So, why do I need to know this? If we go to the next slide here, a new compressor comes filled with an entire system full of oil. All the oil that's needed to fill that system is right there in that new compressor you get. So if you have a catastrophic failure on a system, you gotta buy a new compressor. You're gonna change out the condenser, you're gonna change out the dryer, you're gonna flush out the hoses, you're gonna flush out the evaporator and the expansion valve, clean them all out, get all that debris out. In getting all that debris out, you also took all the oil out. Well, now that system's all ready to reassemble, you put all new pieces on, pulls the compressor right up, it's already got the oil in it needs. Put it in the vacuum it down, you're all ready to go. But we don't always have a catastrophic failure, sometimes it's just the clutch that fails. So it's just the clutch that fails, and you bolted that up, now you got way too much oil in the system. Because you haven't taken any oil out of the system, other than the amount that you might have taken out with the refrigerant. So, if you have a new compressor that you're putting on, and all you're doing is changing that compressor, you need to adjust the amount of oil in that compressor. Take the old compressor, open it up and pour the oil out into a measuring cup. See how much oil you get out of that compressor. That compressor oil that you get out is what you need to put back in with the new compressor. But remember, we're going to change out the dryer also. So we need 2 ounces for what's in the dryer. We're going to get rid of that. Anytime you change the dryer, you should add 2 ounces to the system. That puts the amount of oil back in where it was from the factory. Containers used for transporting recycled refrigerant must be DOT approved. Talk about that. Gotta have the stamp on it. Refrigerant should never be collected, salvaged, or stored in a disposable container. Disposable containers are disposable. They're not meant for reuse. When you get done with a disposable container, hook it up to your vacuum pump. Put it in the vacuum. Close the valve off, mark it with MT on the top of it, send it off to the landfill, throw it in the trash. The grader up there is going to run over it, it's already in the vacuum, it's going to squish down to a piece of metal. Just be another piece of metal in the landfill. Never fill an approved container to more than 60% of its rating, 18 pounds in a 30-pound container. To check refrigerant, if you have recycled refrigerant that you're using, you want to check it to make sure that it meets the purity standards that you're supposed to have. Now, all the manufacturers will send it to you, but in some cases you may have a little bit of non-condensable gas that gets into that container. It's air. Air will raise the pressure in that container. Keep the container out of the sunlight, because the sunlight on that metal will warm it up. We don't want additional pressure. So take it, make sure it's out of the sunlight for 12 hours. Keep it at room temperature. Measure the pressure in the container. Get your pressure temperature chart out. Check it to see where should your pressure should be. If the pressure is lower than what it says on that chart, you're good to go. It's just straight refrigerant. If it's higher, it's got non-condensable gas in it. This is strictly for recycled refrigerant. Most retailers are going gonna sell what they call virgin refrigerant. It's brand new, never been used, it's straight from the manufacturer. But there are companies out there that do sell recycled. If you buy recycled, make sure you're checking. If you've got higher pressures, we need to vent that air out of that container before you use it. You hook it up to your recycling machine, it will pull out just a small amount, pressures will equalize out, you'll be good to go. Recyclable recovery recharge equipment has standards that it must meet. If it's 134, it's J2810. Again, you'll never remember all these standards. It's okay, we'll work through that. The key new thing is 1234 is required to have a refrigerant identifier built into it. Now, the other thing that the 1234 machines do for you is when they pull a vacuum and you basically set it automatically, it will pull the vacuum for you, it will put a 10% charge into the system. Then it will check that system for pressure. If it doesn't get the reading that it wants, it's not going to let you recharge that system. It's going to tell you there's a problem, you need to fix that problem before you can charge it up. If it sees the pressure it's looking for, it'll put the final charge in. They're making it pretty much automatic for us. Vacuum pump. Vacuum pump is a little engine. That's what it is. It's got oil in there. It is not refrigerant oil. It has its own oil. Make sure you're using vacuum pump oil. The vacuum pump pulls everything in that system out and pushes it out of that system. That vacuum pump will have a small amount of whatever's in that system get into the crankcase on it. It'll contaminate it over time. We need to change that oil, and Winebrenner recommends every 10 hours of operation. So how do we know if it's been 10 hours of operation? Because we don't sit there and count every time. But we do know how many times it's been used in the shop. It takes a half an hour to evacuate a system out. So a half an hour per truck, 20 trucks, we need to change the oil in that vacuum. Just a little bit about 1234. It's a colorless gas, it's a replacement for R34, 134. It's used in the automotive air conditioners. It's the first of a new class of refrigerants. They're testing them all for this global warming potential. This one has a global warming potential of 4, fairly low. It's been used since 2006 in the European arena. They chose this because of its low GWP. There was a little bit of controversy over the fact that it is slightly flammable. It does take spraying this refrigerant and an oil mixture onto a 900-degree surface in order to get it to ignite. In the automotive world, there's not many surfaces that are 900 degrees. If they are, they don't last long. So that's why they decided to go with this. It also, like I said, has the lowest switching cost for automakers. The components are very similar, pressures are very similar, it's really easy for them to switch over to it. It is released into the atmosphere. It will mix with moisture and it will cause an organic acid, but it's a mild organic acid. So as far as anything that we've got so far that we can release into the atmosphere that would not harm us, this is our best choice. We do not want to release it to the atmosphere if we can keep that from happening. Use your recycling recovery machines. All right, so get into some troubleshooting. System comes in to see into your shop. First thing you want to do is a visual inspection. Check for these service caps. Service caps must be kept in place. The main reason for keeping those in place is that's your access point for putting refrigerant in, for putting oil in. It's going to have a small coating of oil on it. Oil attracts dirt. If you hook up to it and that cap's hasn't been on there, you hook up to it, you're going to shove that dirt right in that system. If it's missing a cap, clean it. Get it as clean as possible. Find another cap for it. Get a cap put on. So when you're done, it's capped off. Majority of all CFCs released into the atmosphere come from air conditioning service and repair, not from leaking systems. There's a lot of the old history in here. CFCs are the R12. And R12 was prior to having the recycling machines. You had the tank you charged from, you had a vacuum pump. In between, there was nothing. When it came in for repair, and by the way, I'm guilty of it myself, brought it in, had a leak, well, still got a little bit of pressure, we just vented the atmosphere. We didn't worry about it. We didn't realize what it was doing. Nowadays, use your recycling machine. If it's been more than a year since the last AC system, check for low refrigerant charge. You get a leak somewhere more than likely. You've also got a saturated dryer. That dryer is pulling any moisture that gets into that system out. It likes moisture. And it doesn't take very much to fill that dryer up. If it's been less than 3 months since the last AC system, now you need to see who worked on it last time. What did they do? Because apparently they didn't do it right. They missed a cut O-ring, they missed a dryer, they didn't change it out. Something caused that system to fail, not working like it should. When you hook up to it, run the vacuum pump for 15 minutes, turn the pump off. It should hold a steady vacuum for 5 minutes. Gotta hold that for 5 minutes. You wanna make sure that there's no leakage in there. You gotta make sure there's no blockage that's leaking across internally. If it holds, run the pump for an additional 15 minutes. That finally gives everything a chance that's inside here, because the refrigerant is going to boil off, but if the refrigerant's mixed with the oil, it's going to take a little time for that to do that. So run it another 15 minutes to make sure you get all the gas out of that system. Shut it off, it should hold for 2 more minutes. Then you're ready to recharge. Undercharge can result in poor cooling or even worse, poor lubrication. If you've undercharged the system, more than likely you've also under-lubricated it. It's got less oil than what it should have. If you're running 150 pounds and 10 pound on the low side, you're probably undercharged on this, but you could also have something that's starting to restrict in here. Keep an eye out for the temperature outside when you're charging the system up. If you're overcharging the system, you're going to have higher pressures. At 55 pound on the low side, best you're going to get out of the evaporators at 55 degrees. Driver's not going to be happy with that. If you've got a high side and a low side, as this one's showing, you've got a blockage somewhere. Your dryer could be completely plugged up. Your expansion valve could be plugged up. The compressor is working its little heart out. It's trying to build the pressure so that you've got it, but on the low side, you've got a vacuum. You've got a restriction somewhere. On the other side, you can't build good pressure on the high side and you're not being able to pull it down on the low side. Your compressor has failed. Head gasket, valves inside, something there is not allowing it to build the pressure. It's bypassing internally in the head. So the compressor has failed on that one. Any questions for anyone?